Hi friends, welcome back to my channel. Today we are going to be learning a very easy topic called set theory. Okay, we're going to start with introduction. What is set theory? What's set? Set, simply put, is a collection of items, collection of objects. Simple. It's a collection of objects. For example, in mathematics, we have a collection of even numbers, 2, 4, 6, 8, 10, and so on. We have a collection of odd numbers, 1, 3, 7, and so on, 1, 3, 5, 7, and so on. We have a collection of positive integers, a collection of negative integers, a collection of irrational numbers, a collection of rational numbers, and so on and so forth. So basically, set is a collection of items or a collection of objects. Now, how do we note set? How do we write down? How do we denote set in mathematics? Now, the appropriate way to denote set is in curly brackets, not a square bracket. You don't use this kind of bracket to denote sets. You do not use this kind of bracket to denote set. It must be a curly bracket, and the name of the set is usually a capital letter. For instance, let's call this set of even numbers. We might call it set E. We'll denote it with a capital E. Okay? Or we want to denote it with A. Denote it with capital letter. So usually we name the sets with a capital letter. This is the way we're going to represent our sets. Sets are represented with curly brackets, not this. And the elements of the set, which are the components of the set, the members of the set, are separated using commas. You must separate the elements using commas. You can't just write them randomly like this. 2, 4, 6, 8, and so on and so forth. Now, if the elements of the set are so many, you can't write all of them down. That's where this nice thing comes in. These are called ellipses, and so on. These are used when you cannot exhaust all the elements of that particular set. Let's say there are a lot and you don't want to write down all of them. You use this to show that there are more coming. There are more elements. You just want to write this down. Okay, so let's talk about notation of set. We've talked about representing the set using capital letters, and we talked about using curly brackets to represent the set, and we also talked about separating the elements of the set, which are the objects we're talking about, the collection of the objects that are in question, separating them with commas. Okay, now let's take some examples. Let's say set A is a set of all factors of 10, 1, 2, 5, and 10. Okay, so we can say that 2 is an element of A. 2 is an element of A. We denote this using this symbol. 2 is an element. That means 2 is contained in the set A. Or we can say 5 is an element of A. So 5 is a member of the set A. But what is not here is 4. So if you're asked, is 4 a member of set A? You say no, 4 is not a member. This is how you denote not a member. 4 is not a member of set A. Now we've treated this and this. Let's go to types of sets. We have a few types of sets. First, we're going to talk about the empty set or the null set. An empty set is a set that has no element in it and is denoted using this. You denote it using this or this. This shows an empty set. Once you see this, you know that there is no element in that set. For example, a set of all prime numbers that has 1 in it is empty because there are no sets of prime numbers that contain 1 in it. So that's an empty set. Okay, another type of set is a finite set. A finite set is a set that is countable. Okay, for example, set of all factors of 10, countable, is finite. Set of all factors of 100, countable. Set of all factors, positive factors, not including negative factors. Set of all positive factors of 30, they are all countable numbers. So they are called finite sets. Next type of sets we are going to look at are infinite sets. Infinite sets are uncountable. Example, set of all whole numbers. Whole numbers extend from 1 to infinity. They are uncountable, so they are infinite set. That is when this ellipsis I talked about comes into play. So if you want to denote set of all whole numbers, Let A be the set. Whole numbers 1, 2, 3, 4, 5. When you get tired of writing the numbers, you extend it using this. This shows there are more elements of the set that you're willing to write that because they are infinite. So set of all whole numbers are infinite, set of all integers are infinite, set of all rational numbers are infinite. Any set that cannot be counted is infinite. Another one we're talking about are subsets. Subsets are a set that is contained in a larger set. For instance, set of all whole numbers that lie from 1 to 50 would denote it as A equals 1, 2, 3, 4, 5, dot, 50. This shows there are numbers in between that you do not want to write down because there are so much. The numbers in between, but the last number is 50. Remember, this is a set of whole numbers that lie from 1 to 50, not between 1 and 50. Listen to the terms. If it were between 1 and 50, then 1 will not be included, 50 will not be included, but this lies from 1 to 50. Now, and I have another set, which is a set of all factors of 20, which includes 1, 2, 4, 5, 10, and 20. All these numbers we agree are inside this set. So we can say that B is a subset of A. That means the set B can be found or is contained in the set. Then we have the last type of set, which is the universal set. The universal set is a set that contains all the sets that are in question. For example, it could be anything. A universal set is not one specific type of set, but given the question, given a particular question, universal set is a set that contains every type of set that is within the question or within the topic that you are referring to. For example, let's take the universal set, which is denoted using this symbol. Universal set could be set of all positive integers. So all of these are here. All these sets are subsets of the universal set because they can be found in the universal set. The universal set is like a broader type of set where all the other smaller sets you're dealing with at that moment can be found. Okay, now let's talk about set operations. What are set operations? Just like in arithmetic, we have 4 basic arithmetic operations, which is addition, subtraction, multiplication, division. In set, we have set operations, which include the union of sets, the intersection of sets, and the complement of sets. Let's start with the union of sets. Let's take 2 sets for example. Let A be a set of all multiples of 3 that lie from 1 to multiples of 3 that lie from 3, obviously, that lie from 3 to 30. Multiples of 3 will be 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. And set B will be set of all even numbers that lie from 1 to 30. 2, 4, 6, 8, 10. I do not want to list all of them, so I'm going to shorten it like this. 28, 30. Okay. So what is A union B? The union of two sets, is the combination of all the elements in the two sets without repeating any elements. So for instance, these two sets, the union of A and B will be written as A union B equals 2. Always take it in order. 2, 3, 4, 6. There are 2 6s here. You don't repeat them, just pick one. Next is 8. Then we have 9, 10. Obviously, there is no 11 because 11 is not an even number. 12. There's 14 obviously here. And then there's 15 here. And so on and so forth until you get to 30. So this is A union B, which is all the elements of set A and B together without repetition and in order. Then A intersection B. A intersection B means what they have in common. What is in A and is repeated in B? So looking at it, we know that 6 is in 2 of them. So we have 6. Then obviously 9 is not there because 9 is not an even number. So what we're going to basically be picking out are all the even numbers that are here, because they'll be the only ones that they have in common. All the even numbers that are here obviously are here. So let's pick all the even numbers: 12, 18, 24, and 30. So this is A intersection B. All the elements that are common to A and B. Also, you take them in order. Also, there's no need to repeat any number. So this is A intersection B. Now we have the complement or the prime. So we have, it could be A union B prime or A intersection B prime, whatever the question. So A intersection B prime implies that there is a universal set. That is, there's a bigger set, a universal set that is bigger than A and B. So for you to get the complement, there must be a universal set. There must be a set that is bigger than A and B, which you're taking reference to. So let's take the universal set to be set of all positive integers. That will be the universal set. Okay. So A intersection B prime means this set here, everything that's in this set, okay, or rather everything that's in the universal set that is not in this set. So you're going to take away this set, the elements of this set from the universal set, and that will be your A intersection B prime. So we're going to have everything here will be subtracted from everything here. So if all your positive integers begin from 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 you're going to exclude all of this so that you have 1, 2, 3, 4, 5, exclude 6, 7, 8, 9, 10, 11, exclude 12, 13, 14, 15, and so on and so on, because we can't exhaust. Remember, the set of all positive integers are infinite. We cannot exhaust all of them. So this is what A intersection B prime means. What about A union B complement or prime? A union B prime are all the elements that are in this set, all the elements that are in this set taken away from this set. So what are the elements? Remove all these elements from the universal set. That will be your A union B prime. So we're not going to have these elements in our operation. So we have 1, we're going to exclude 2, exclude 3, exclude 4, 5, exclude 6, 7, exclude 8, 9, 10, 11, exclude 12, 13, exclude 14, 15, 16, and so on and so forth. They are infinite also. That means A union B prime are all the sets, are all the elements that can be found here but will not be found here. I don't know if it makes sense. All these elements can be found in the universal set, but they will not be present in this particular set. That is your A union B prime. So a quick recap of all we've learned so far. A set is a collection of objects which are called elements in the set. And we've learned that we represent sets using capital letters and curly brackets, and we separate the elements of the set using commas. We also use ellipses, which is this symbol here, when we want to represent the elements that we cannot write down because there are too many or there are a lot. So we usually put a comma before and after the ellipses if we want to write something else, or just like this if we want to end the set. Okay. We also learned different types of sets, the empty set or the null set. We learned about the finite sets, which are countable sets, infinite sets, which are uncountable, and the subsets, which are smaller sets that are contained in bigger sets. Then we learned the universal set, which is the mother of whatever set that I give it at a particular time. There is no specific set that is called the universal set. It all depends on the question that you are given or the scenario you are working with. All right. Then we have the set operations, which include the union of sets, which includes all the elements in the given set. The intersection of sets, which means all the elements that are common to the given set, and the complement of the set, which means all the elements that cannot be found in the set but can be found in the universal set. I hope this is clear. So if you've enjoyed this particular topic, please like, give me a thumbs up, leave a comment, question, suggestion, or anything. Please subscribe to my channel also and hit the notification bell so anytime I release a video, you'll be the first to know. Thank you very much. Bye.